discussion. It's just longer than I expected. It's fine. All right, 5.2, exponent rules and rational exponents. Okay, going through this, some of it will be review. Okay, and we're adding on to a lot of stuff you learned in Algebra 1. Going between radical exponent and radical form, rational exponent, sorry, and radical form, we need to be able to go back and forth between both. So we're going to do a lot of that today, and then we're going to expand on that throughout the rest of the unit. Okay? For the x raised to the power over a root, does anybody know what that x is called in terms of rational exponents? Or just exponents in general? Appreciate that honesty. No clue. Good. Okay.
It doesn't say it right there.
No.
I don't even know what
What's it? Right here. X raised to the power over a root. What is the x called? Okay, it is a variable. That is not an incorrect answer. But in terms of the power over a root, attached to the exponent, what would that be? Not a coefficient. Coefficient would be in front of all of that. It's called the base. That should not be a new word. If that's a new word from Algebra 1, that is bad news. Bears.
It's not a new word. It's a new word.
Okay? So when we see a rational exponent, first off, do we understand what rational means? Okay. It's part of the real numbers, yes. Rational means that it can be put into a fraction form. Irrational is what? No, they're real. Those are real numbers. Yes, they go on forever, like pi. Okay, irrational numbers are never-ending decimals. Okay, rational numbers are values that can be put into fractions. Okay? All right, so bless you. In rational exponent form, the top value in the numerator is the power, and the denominator is the root. Now, looking in radical form, do we know what this is called? Owen? It is the index. Nice. First one to date to get it. I would say he might have the notes open back there, but I don't have it on the notes, so. He just knew it. Good work. Do we know what the value inside is called? No, quotient is a division problem. The value inside the radical. No, that's again in a quotient problem, the division problem. Okay, the symbol is called the radical. The value inside is called the radicand. You've heard all of these, I would hope. If you passed your Algebra 1 SOL, you've definitely at least read it.
It's like you have to make complex stuff.
Huh?
Like they're there.
They're there. Yeah, that's the problem. Yeah. Okay. So we're going to go back and forth between radical form and rational exponent form. Now, if there is no value in our index position, what is it assumed to be? 2. Okay, square root. All right? So square root means that that index is 2. Okay? So taking 9m raised to the 5th, we just take our radicand and change it to radical form. Now, you looked at it at your warm-up. So instead of the square root of 144, we also did 144 raised to the 1/2. Anybody able to simplify that for me? This is going to come into our rules that we're about to review. But we'll see. What's that?
3m4.
Okay, it is 3 because this is 9 raised to the 1/2. And then this is just m raised to the 5 over 2. 9 raised to the 1/2 is 3. So 3m raised to the 5/2. Okay, for B, that's the cube root of y to the 18th. So I could say y to the 18th raised to the what? 1/3. Excellent. Okay, 18 times 1/3. Yes, 18 over 3. And what is 18 over 3? Y to the 6th. Good. The power always goes to the top. Okay? So the power is at the top. The root's like the bottom. It's like it's like the roots of a tree. They're under the ground. Yeah, that was so metaphorical, right? I was using all sorts of English words last time, and everybody was like, "What are you talking about?"
Can't you just put the power over the index?
That's exactly what you just did. Drop the mic. All right, looking at C. Can we simplify that without doing anything?
Yeah.
Yes. What is it?
8.
Wow.
2.
Oh my Lord.
2.
4. Okay. What's my index? 2. Okay. Change it with the power over the root. 2 over 2 is 1. 4 raised to the 1st is 4. What's another way to look at it? What's 4 squared? 4 squared is 16. What's the square root of 16? 4.
I'm just gonna use my mouse.
It's not going to work for all of them.
If it's a 2 and a 2, it'll always work.
Well, you know, the next problem's not going to work.
Correct. The next problem doesn't have a 2 and a 2. If it had a 3 and a 3, it would work.
Oh my.
Okay. All right. My base and my radicand are the same. So my base is 7. My power is 4. My root or my index is 3. Don't you need you to simplify that at all. We'll get into that later. Huh? A later day. Yes. We're taking baby steps. Hopefully just trying to get your brains to remember that you actually know all of this. Okay, write the following expressions in radical form. So now we're going the other way. So our base becomes our radicand. What's my index? 3 over 5. What's my index? Look at the top.
Top value.
Your index is 3 over 5.
No, my root or my power is 3 over 5. My rational exponent is 3 over 5. Abigail?
Two, right?
The index is 5.
My index is 5. Thank you.
How do you know that? Oh, because it's over.
Look at the top of the next.
Okay, where's my 3 go?
In the exponent.
Okay, so it can either go here
Or outside.
or outside. Both are correct.
Is there any instance in which it's
No, it's always correct. Those are inverses of each other. So in terms of orders of operations, it doesn't actually matter which one goes first. Sometimes one's easier than the other. Okay? But it doesn't actually matter which one goes first. Okay, like in C, this C, we could have also said the square root of 4 is 2, and then squared that, and still gotten 4. Okay, B would be written as the cubed root of R squared. And whether you write the squared right next to the r or higher than the value, totally fine.
Can you write like A too?
Yes. You want to see how it's written? Yeah, Andrew.
So they don't use numbers if you work backwards.
So sometimes with the numbers, let's say you're taking like the cube root of 8 to the 5th. Do you know 8 to the 5th? Do you know the cube root of 8? So which one would you want to do first? The cube root of 8. Okay. This one's not already implied.
She's talking about C. She's talking about C.
Oh, you don't need to write it. However, what's 4 over 2? 2. Okay, now D is kind of an example that Andrew was just talking about. If I rewrite this, cube root of 8, let's do it cube root of 8 squared, or cube root of 8 squared.
Wait, but it says simplify. You can simplify.
It does. Okay, cube root of 8 is 2. 2 squared is 4. Okay, let's look at it differently. 8 squared is 64. Cube root of 64 is 4. Did it matter which one we did first? Nope.
The top one is easy. For sure.
And that's to each their own. All right, pull out that 5.2 notes exponent rules that you also picked up. Okay, if you lift that up to light a little bit, you'll see the line right at the bottom, or not the bottom, going around, going from top to bottom. Try and fold it right on that line. Danielle, you got it? Oh. Well. Here you go. I'll write it for you. You can write it for me, and then I'll give it back to you. No.
Oh, what is it? This is sixth grade.
Do you want me to write yours? No, you write it? Okay, now, I'm not going to pass around scissors right now, but if you have them, you're just going to cut where the lines are on the notes, because if you open them up, it is a foldable. I just love those, except you never use them. Okay, I'm not gonna cut much more. Hope when you get this, you can cut more if you'd like. That's as far as I'm gonna go. Okay, we're gonna do the front together, and then I'm gonna give you a little bit to do the inside. So basically, if you're thinking about quotient of powers property or a similar problem, you would take that and you can open it up, and you'll have two examples that you can reference when you're doing your homework and studying for your quiz. That is next class. Okay, rational exponents. We need to be able to go back and forth between the nth root of a to the m is equal to a raised to the m over n. Okay. Product of a power property. Does anybody remember what you do when you have the same bases? What do you do with your exponents? How do you combine them? We add them. Good. So same base. Okay, only add the exponents. You're not multiplying the a value that's already happening with the operation. So it's not 2a raised to the m plus n. It's just a raised to the m plus n. Okay, power of a power property. What happens there?
You multiply.
Yes. So that's a raised to the m times n. Power of a product property, that just says that the exponent gets put to both values. So this would be a to the m times b to the m. What happens when you have a negative exponent?
The I.
Nope. It's not the square root of it.
The Q.
No. Nobody remembers?
So do you make the a negative and
No, and that is a very common misconception. Okay? When you have a negative m,
Just make it times -1 and just make it positive.
nope. Because where does that negative one come from? Okay?
Don't you
Magic.
put a denominator?
Yes, you move it to the denominator. So this is 1 over a to the m. The only thing that changed was the m value. Moving to the denominator, the m became positive. Now, what happens if we have 1 over a to the negative m? What would that end up being? A to the m, just a to the m. Okay? So if there's a negative exponent, it's in the denominator, it moves to the numerator. If there's a negative exponent, it's in the numerator, it moves to the denominator. Okay? Yes?
Oh, I'm just gonna answer.
Great.
Is it 1 to the m minus n?
Where'd you get 1 from?
I don't know.
What's the base?
What?
What's the base?
A?
A. So
Oh,
A.
okay, so yeah, A.
Okay, same base. Whoops. A raised to the m minus n. Yes, when we have product of a power, we add the exponents. When we have quotient of powers, we subtract. Okay, power of a quotient, this is similar to power of a power. Okay, or power of a product, sorry. That is a to the m over b to the m. Fantastic.
you have to memorize all these things using all the names.
Not the names of them, but you need to know what happens. Yes.
So it's not going to be like,
Oh, it's not going to be like match this property to this name of this property.
it will just say like,
It'll just be simplify using the properties of X. All right. Anything else from your foldable? Yes. The a to the 4 raised to the 6. This one. Okay. So when you have the same base, you subtract the exponents, right? Okay. So I have the same base of r. So I have r1 minus 7. Okay. What's 1 minus 7? 6. But it's a negative 6. Okay. So r raised to the negative 6 is equivalent to 1 over r to the 6th. Okay. Now what about the t to the 15th over t to the 10th? That's the same base. 15 minus 10 is t to the 5th. So t to the 5th is good. Really, I'm taking t to the 5th. Now times 1 over r to the 6th. Oops, t to the 5th. And that's how I get there. Okay? Anything else for your foldable? No, No, we got the rest of your notes to do. Alright, go back to your notes. Okay, exponent of 0, that's another rule. Does anybody remember it? Owen?
Means one.
Not times 1, not times 0.
Just be one anyway.
It's just 1. Anything raised to the 0 power is equal to 1. Okay, and A and B kind of show you exactly why that is. Okay, 4 squared over itself, 4 squared, anything over itself should be 1. Okay, well when I have the same base from our exponent rules, when I have the same base and I'm dividing, what do I do with their exponents? I subtract. Okay, 2 minus 2 is 0, so 4 raised to the 0 is 1. Okay, anything over itself gets you 1. So when we have this, 4 raised to the 0, we also have 1. Okay, so x cubed over x cubed, what should that be? That's over itself. Whatever quantity that's going to be is over itself, so that should be 1 as well. So if I do it with exponent rules, x raised to the 3rd minus 3, x to the 0, so I have 1. Okay, what about 4ab raised to the 0? What has the exponent of 0? Just the b. So b to the 0 is 1, so I'm still left with 4a.
It would be plus one.
Nope, it would be times 1, because everything here is being multiplied.
Oh, yeah.
Okay? So d 4.68 raised to the 0, what is that? 1. That's a whole quantity raised to the 0 power, so that is 1. Okay, that's probably the only rule that's not on your foldable. Alright, example 3, simplifying expressions using exponent rules. So these are going to combine multiple rules. Okay, and as you're going through, you need to start recognizing what the best route to go would be. So looking at A, do we know what 3 squared is? Yeah, okay. So 3 squared is 9, which means we would then be taking 9 raised to the 5th. Do you know what 9 raised to the 5th power is?
No, what is it?
I don't know it off the top of my head. What about 3 raised to the 8th? Do you know that off the top of your head? No, I don't. Okay, so you need to recognize that right now we have the same base. Shh. Right now we have the same base. Okay, so 3 squared raised to the 5th is what? 3 squared raised to the 5th is
Isn't
what?
that just 3 squared, everything to up to the power of 2 times?
Yes. So that would be 3 raised to the 10th over 3 raised to the 8th. Do I still have the same bases? And I have a quotient, so what do I do with their exponents? Subtract. So this is 3 raised to the 10 minus 8. What's 10 minus 8? What's 3 squared? Is that a lot easier to simplify than doing 9 to the 5th divided by 3 to the 8th? Okay. Alright, now for B, you need to think about your orders of operations while you're going through these. So your orders of operations states that what happens first? Parentheses. Okay? So my parentheses, I'm going to multiply. So just bring those together. 6t to the 6th u squared over 3ut raised to the negative 2. Now, I just combined them. Did I simplify anything? I didn't simplify anything yet. So let's look. 6 over 3 is 2. T to the 6th over t would be what? 6 minus 1, so it would be t to the 5th. Okay? U squared over u, what would that be? Just u. Raised to the negative 2. Okay, so that means everything is getting that negative 2. So let's take care of the negative first. Okay? The negative exponent means that I do what with anything in my numerator?
Look at the denominator.
It moves to the denominator. Okay, so this becomes 1 over 2t to the 5th u. Now I took care of the negative, but now it's still squared. Now everything gets the square. So 2 squared is 4. T to the 5th raised to the 2nd is t to the 10th. U to the 1st raised to the 2nd is u squared. Okay, that next one is all a multiplication problem. I would try and match things up that can be multiplied together. So I have 3a, a cubed, and negative a cubed. So I'm going to line those up together. 3a, a cubed, and negative a cubed, along with that 4b to the negative 4 raised to the 1/2. Does that negative have any effect with the 3? Or does the 3 have any effect of that negative? No, it doesn't. Okay? So that negative is really just a negative 1 that can be multiplied to the 3. So I would have negative 3. A to the 1st plus 3 plus 3. So what is this? Negative 3a to the 7. Good. Okay, and then 4b raised to the negative 4 raised to the half. 4 raised to the half. B raised to the negative 2. What's 4 raised to the 1/2? 2. What's b raised to the negative 2? Where does that go? 1 over b squared. Good. Okay. Now all I have to do is multiply across. Negative 3. Oh, negative 6. My bad. Yep. You got it. So I usually use pencils.
It's 250.
You got it.
Hey, we still almost have a
No, we spent a lot of time talking and allowing ourselves to just dilly-dally because I gave you a lot of time to do that foldable that shouldn't have been. Wasn't as bad as last time. This video is 28 minutes instead of an hour and 10. Alright, I need you to do D, E, and F for homework. I will have those up on there. You are not done. I still have 5 minutes. I gotta give you your homework, your actual homework.
Oh, wait.
Yeah, we're still not done.
Let's not.
Okay. Alright, flip to the back real quick. Operations and plugging into function notation. So this is very much from Algebra 1, but we do need to review. So operations and plugging into function notation. Looking at this, I have f of 4. And I have f of x. So the 4 took the place of the x. So anywhere I see an x value, I'm going to plug in 4. Then I'm going to simplify. 2 times 8, or 2 times 4 is 8. Minus 1 is 7. So f of 4 is equal to 7. G of negative 3. Again, replace the negative 3 with any x value and simplify. Negative 3 squared is 9. 3 times 9 is 27. Minus 4 is 23. So G of negative 3 is 23. Okay, looking at C, I have f of 4 plus g of 3. Well, we already did both of those operations. F of 4 is 7. G of negative 3 is 23. So f of 4 plus g of negative 3 is what? 30. Okay, you can also do those as two different operations happening at the same time. Go ahead and do f of 2 times g of x. F of 2 is 2x minus 1 times g of x, which is 3x squared minus 4. I should have this in parentheses. 2 times 4 is, or 2 times 2 is 4, minus 1 is 3. So I have 3 times 3x squared minus 4. Distribute that 3. You end up with an expression, 9x squared minus 12. Do not pack up yet. I want you to open that back up and go back to D, E, and F and work through those until that bell rings.
Yeah, it's all done.
You did get your notes all done. Good job.
No one else did.